8.1 Pythagorean Theorem and its Converse. Everyone should have learned the Pythagorean Theorem at some point, probably in middle school. And most of you guys remember it as a squared plus b squared equals c squared. But before we get into that, we want to look at review of solving equations involving radicals, square roots, and simplifying radicals. So let's look at example 1. X squared is equal to 64. Now we're trying to solve for x, and as we discussed before, in order to undo radicals or undo squares, we need to use a square root. So we're going to take the square root of both sides. So this leaves us with the square root of x squared, which is x, and the square root of 64 is 8. Okay, this step is important because this is how we're going to solve most of our Pythagorean theorem problems. So let's look at example 2. Y squared equals 9. Square root of y squared, which you do one thing to one side, you have to do it to the other, so this becomes y equals 9. Number 3. Y equals 3. Now, one thing I forgot to mention is that this is always going to be plus or minus when you take a square root of a number. But because we're dealing in geometry with just distances, and most of our numbers will always be positive. Okay, because distance is always measured in positive lengths. So let's look down here at number 3. The square root of it, or m squared, is equal to 16. Square root of m squared, square root of 16. M is equal to the square root of 16, which is 4. Going down to number 4, 81 is equal to b squared. Notice that the b squared is over on the right, 81's on the left, and it doesn't matter. It's still the same operation. We're going to take the square root of b squared, the square root of 81, and b is equal to 9. Now, on numbers 5 through 8, everything's a little bit different now. One thing you'll notice is that none of these over here are perfect squares. So what we're going to do is called simplifying radicals. Now I know some of your calculators will do this, but you need to understand the process for when you get to Algebra 2. So x squared equals 12. We'll take the square root, that gives us x. Now, since we do not have a perfect square here, what we're going to do is we're going to break this apart to two factors where one factor is a perfect square. So two factors that go into 12 are 2 and 6. 3 and 4, but neither 2 or 6 is a perfect square. But 3 and 4 has a perfect square in it, and 4 is a perfect square. So we're going to break this apart to be 4 and 3. The square root of 4 is a perfect square. The square root of 3 is not. So the square root of 4 can come out to become a positive 2, whole number 2, and what's left inside is radical 3. Since radical 3 is not a perfect square, this becomes our solution to radical 3. Let's look at the next one. Number 6, y squared equals 18. Square root of y squared, square root of 18. Y is equal to, now we're going to break this apart, and we're going to use square root of 9 times the square root of 2. So y is equal to 3 radical 2. Once again, the square root of 9 is a positive 3. 3 comes on the outside. Radical 2 does not. It stays on the inside. Number 7, we're going to take the square root of both sides. Now, the two factors that give us the square root of 21 is 7 and 3. Neither of those are perfect squares, or 1 and 21. And since neither is a perfect square, our answer is just going to be the square root of 21. Now, this one here, we have b squared is equal to 32. Square root of b squared, square root of 32. Square root of b squared is b. The square root of 32 can be done a couple different ways. Now, if we take this apart here and we think of 8 times 4. Okay, so we take 4 and we take 8. Now, the square root of 4 is 2. And then we're left with 2 square roots of 8. But, as you know, 4 goes into 80 as well, and that's a perfect square, so we have to simplify again, which means we're going to break 8 apart to become 4 and square root of 2. So now we bring this 2 straight down. 8 is made up of 4 and 2. And so now we can simplify the square root of 4. So we bring this 2 straight down. Square root of 4 is 2, so we're going to multiply it by anything on the outside. And we're left with radical 2 here. So 2 times 2 is 4. And we're left with 4 times the square root of 2. One other way to do this is if you take the largest perfect square. If we look and notice that 4 and 4 are both perfect squares that we simplified this down to. We take our 4 and 4, multiply those together, that gives us 16, which means that would have been the largest perfect square. So if we started over at 32, we could have taken the square root of 16 times the square root of 2, because 16 times 2 is 32. The square root of 16 is 4. Bring down the radical 2, and our answer is 4 radical 2. A much simpler process, and it's just like simplifying fractions. If you take the largest common denominator first, or common factor, when you're simplifying a fraction, you simplify it down much quicker. Same thing with radicals. All right, so let's move on to the next slide. Pythagorean theorem. If you know the lengths of any two sides of a right triangle, then you can find the length of the third side by using Pythagorean theorem. It's commonly known as, we know it as a squared plus b squared is equal to c squared. A and b are both legs of the triangle. C is what we call the hypotenuse. It's always the longest side because it's always across from the right angle. So anytime you have a right triangle and you're trying to determine which one is the hypotenuse, just remember it's always across from the right angle. It's also the one that's always by itself in the equation of a squared plus b squared is equal to c squared. And one thing I also want to note is that the Pythagorean theorem only works for right triangles. That's because the only triangle that has a hypotenuse is a right triangle. Next, we're going to look at a Pythagorean triple. A Pythagorean triple is a set of whole numbers that satisfy the equation a squared plus b squared equals c squared. These are all whole numbers, not made up of fractions or any decimals. 3, 4, 5 is the basic right triangle. If you took 3 squared, 4 squared, it should be equal to 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. Same thing with 5, 12, and 13. This is a Pythagorean triple. And these are just 3 examples of them. There's many examples that you could get to be a Pythagorean triple. In fact, one way to do it is you can take any Pythagorean triple and multiply each side length by the same number and create another Pythagorean triple. Such as I could take 3, 4, and 5, multiply each by 2, and that would be a 6, 8, and 10. You can multiply it by 3, that would be a 9, 12, and 15. All right, in example 1, find a missing side length. Express your answers in simplest radical form. So let's take a look here at part A. We're going to work this one together, and then I'll give you a chance to work part B. So we've been given the 2 legs. The 2 legs are the ones that meet at the right angle. So as we set this up, we're going to take both legs, 21 squared plus 20 squared is equal to, now since there's nothing over here, we can either use any variable we choose. We're just going to use the lowercase letter c, which represents side c, and the hypotenuse. So it's equal to c squared. So now we take 21 squared. We square that, and we get 441. 20 squared is 400, and it's equal to c squared. So now we add 441 and 400 and get 841 is equal to c squared. Now we have a situation just like the practice problems we begin class with. Take the square root of both sides, and c is equal to the square root of 841, which comes out to be 29. So c is equal to 29. Now, if any time you need more time, just pause the video and come back to it when you're ready. So let's look at example B here. You guys work this, and I'll come back and explain what happened. now that you've had a chance to work it, let's see how you did. We take the two legs, which one leg is x, our variable this time, x squared plus 8 squared is equal to our hypotenuse, which is 20 squared. Remember, the hypotenuse is always the one on the equal sign by itself. So we've already got x squared, so we'll bring that straight down. 8 squared is 64, and 20 squared is 400. We'll now subtract 64. X squared is equal to 336. Now we'll take the square root both sides. Gives us x. And now we can simplify this down, and we can just look, it's kind of a guess and check which factors. We know that because 4 goes into 36, 4 will go into 336. And so sometimes if 4 goes into it, I'll try 16 because 4 goes into 16 as well. In fact, 16 does go into this 21 times. So we have 16 times the square root of 21. And I'll write this up here. Square root of 16 is 4. And that leaves us with square root of 21, which remember does not have a perfect square in it. So our answer for x is 4 radical 21. Now some problems don't always have you simplify the radical. Sometimes they'll ask for it in a decimal form, which means we plug it in our calculator. And in this case, 4 radical 21 would come out to be approximately 18.3. So if you plugged it in your calculator, you can check to make sure you got that correct. All right, now let's look at part C. You try this one, and we'll come back to it in just a second. All right, so let's make sure we set this up correctly. If you ever are confused of what it's supposed to look like, you can always draw a picture. So a hypotenuse of a right triangle has a length of 12. One leg has a length of 6. What is the length of the other leg? So if we were going to draw this out, we'd have our right triangle. Doesn't matter what it looks like. Put our right angle in here. Now, hypotenuse is 12. One leg is 6. Looking for the other leg. So we put an x, or you can put any variable you choose. So as we set this up, it is our 2 legs squared, so x squared plus 6 squared is equal to 12 squared. So bring down the x squared. 6 squared is 36, and 12 squared is 144. Subtract the 36. X squared is equal to 144 minus 36, which is 108. And now we take the square root of 108. Now we're going to put this one in simplest radical form, which means we're going to simplify the radical. And so we're looking for a number that goes into both 108, where 1's a perfect square. So you notice that 1 plus 8 is 9. That means 9 goes into 9 evenly, so 9 goes into 108 evenly. So if we broke this down to 9, it would be 9 times, what is that, 12? Okay, so we have the square root of 9 times the square root of 12. Now the square root of 9 is going to be 3. Bring down the square root of 12. Now, see if 12 can be simplified, and it can because 4 goes into it. So we have 3, radical 4, radical 12. So we bring the 3 down, the 4 becomes 2, and this should have been 3 right here. And so since square root of 3 cannot be simplified any further, we bring the 3 down. Now we multiply the 3 times 2, which gives us 6 radical 3. So you could have also just taken the square root of 108, and this decimal answer would be approximately 10.4. It's important to know how to do both. It's easy to get the decimal answer, but this is usually the tougher method, so it's good to practice getting this. All right, now let's move on to example 2, finding distance. Jamal leans a 12-foot ladder against the side of the house. The base of the ladder is 4 feet from the house. To the nearest tenth of a foot, how high on the house does the ladder reach? On any time a word problem, I like to draw a picture. So we set up the ground. Now we'll draw our house. Nothing perfect, but we know it's going to be perpendicular to the ground. As you can tell, I'm not an artist. Now, the next thing we're going to do is we're going to lay this ladder up against the house. So here's our ladder. Now, this ladder is 12 feet long, so we're going to put 12 feet right here. It says the base of the ladder, which would be the one next to the ground, is 4 feet from the house. So we have 4 feet, and that means we want to know how high on the house, which means this is going to be our x. Once again, this is our right angle. And now it's time to just set up our Pythagorean theorem. So we have our hypotenuse is 12, which means it's going to be by itself, which means the other two are legs. X squared plus 4 squared is equal to 12 squared. Now, typically on word problems, we're going to be rounding to the nearest foot or decimal place. So always look to see what they're asking to round to as you begin your problem. X squared plus 16 equals 144. Subtract 16. X squared is equal to 128. Take the square root, both sides, and x is equal to approximately 11.3 feet. All right, you guys try example B. All right, let's see how you did. So, television. It's going to be sold by the length of the diagonal across the screen. So if a 48-inch television screen is 42 inches wide, how tall is the screen to the nearest inch? So let's begin by making our rectangle. We have a rectangular shaped television, and the diagonal here is distance across our rectangle. Now, it's a 48-inch TV, which means the diagonal is 48 inches. It is 42 inches wide. We want to know how tall is the screen. So there's our x, there's our variable, x number of inches. So, a rectangle has a right angle. So therefore, we're going to have x squared plus our other leg squared, which is going to be 42, is equal to 48 squared. So as we square these numbers here, we get x squared plus 42 squared, which is 1,764. 48 squared is 2,304. Now we're going to subtract 1,764 from both sides. And that gives us a difference of 540. Square root, and you should have gotten x is equal to the square root of 540, which is approximately 23.2379, which is about 23 inches tall. That concludes part 1 of 8.1 notes.